Welcome back. In this video, we will learn about the mutable variables. Remember when we explained how we actually declare a variable in OCaml by using the keyword let, so let x equal 5, for example, in something, or we can have it like, for example, global, something like that. Doing it this way, this is the standard way in OCaml, but doing it this way is like declaring a constant, so like we define a constant. Basically, the variable is sort of set to this value, and this can be int, float, string, char, or boolean, or even a unit. Like for example, let's say t equals nothing. Sorry, unit, and this variable will not be allowed to have another value. We won't be able to reset it. Now, to have an hence it becomes immutable, yes, but we have to have a mutable variable, a variable that we can change its value. Then we need to use something different. There's a keyword in OCaml called ref. It stands for reference. So what we need to do is we need to declare that variable as a reference, or of type reference, sort of. We can say, for example, let x equal ref equals ref 5, and as you can see here, it's telling us that x is of type reference, yes, is of type reference, and it has content value of 5. So basically, if we say x now, it'll tell me that x is of type reference and value of 5, or content of 5. If we want to get the actual value, we use exclamation mark of x. So exclamation mark, exclamation x gives us back the value, and this is the same for string. So let s equal ref string str, for example, and then if we want to get the value of s, we do s exclamation s. If we want to update it now, what we say is we say x, for example, for the integer value, equals colon equal and the new value. So now x now is what is 3, or for the s colon value test, and then now the value of s now is is test. Remember the exclamation mark, the difference is here we are getting the reference, the sort of like reference type, and the we want, when we want to get the actual value, we actually use the exclamation mark. So if we go back now to our while loop earlier that went on forever, maybe we can, okay, I don't have it here, but what we can do is we can say, for example, so now we have x is 3, right? So we can say, for example, while, and now remember, now the value of x, that's how you get the value using the exclamation, is less than 10, do, for example, print string, or print int, as we saw before, print string, for example, uh, hello world, and then slash n for a new line. And then what we do now is we sort of change the value of x. Let's say as long as it's less than 10, so we can increase it. We can say, for example, um, x equals the value of x plus 1. That's how we do it. Sorry, plus 1. That's how we do it. And then we say done. And as you can see, it print x 7 times. Because it's actually x less than 10 rather than less or equal. And now the value of x, what do you expect now the value of x will be? The value of x now is actually 10, because we actually updated the value of x. Now let's try, for example, and declare two reference variables and give them the same value. Let f1, for example. By the way, variable in OCaml can start with small capital letters, with underscore, and even with an apostrophe, believe it or not. So let apostrophe f1, for example, equals ref 3.4 and apostrophe, just to demonstrate that you can use these as variable names. F2 equals if f2 equals ref 3.4 again. Oh, I'm sorry, not in the beginning. Yes, that's my fault. You can't start with an apostrophe, but you can end it. You can have apostrophe even as the last variable. So ref 3.4. What have I done? Yeah, I didn't say equal. I don't know what's happening here. Equals ref 3.4. I don't know what am I doing, but as you can see now it works. And then let, for example, f2 semicolon equals ref 3.4. Yes, so these are two reference variables, float variables of type reference with the value 3.4. Now the equality maybe be demonstrated here. So if I say f1 equals f2, what do I get? I get true. Do you know why? Because the contents now is physically comparing these two guys, so they are exactly the same. And then if I say f1 is exactly the same as f2, what do you expect? It's actually false, although they have exactly the same structure and the same value inside, but they are not exactly the same. If you remember, when we mentioned structural quality and physical quality, they are structurally equivalent, but physically they're not. Physically there are two different variables, but structurally they are equivalent. That's why using a single equal brings me back true, and double equal brings me back false. If I do it the other way around and say f1, for example, not equal f2, then this will be false. But if I do it this way, if I say f1 not equal, again this is physical, not structural equality, f2, then it bring me back false. I'm sorry, bring me back true, because they are not uh, physically the same, they are structurally the same. I hope that makes sense. I hope that makes sense. Difference between structural and physical equality, and this is, I think, a good demonstration. Now remember again that this can be applied to this idea of reference variables or mutable variables can apply to all kinds of variables that we have, uh, especially the the primitive ones, int, float, character, and boolean, string as well, and some other variables as we will see in the coming videos. What did we miss so far? Hopefully nothing much. I hope we are getting sort of to feel the beauty of OCAML. If it's boring, then it's boring. But when we start to save things into files and compile them using a compiler, I'm sure that's when things will start to actually make sense and become clearer. For the time being, thank you very much indeed for watching, and I'll see you next time.